This will be a relatively detailed video on how to do antilogs. Antilogs is what you need when you're going to take an antilog of the pH or pOH. You will always wind up with concentration. So we're going to use our estimating chart, which we showed in the last video, which was made just a few minutes before I made this one. So if we look over here at what was supposed to be there, these charts were on a handout that are available on my website on the homework page for 524, and let's go ahead and give you the year. This is 2016. So anybody watching this video could easily get onto my website and get that. It's website address. So we're going to be referring to this chart a lot, and basically what we had done up to now is we've taken a number and changed it to a log. With antilogs, we're going to take the log and change it back to a number. It's just the reverse process with a couple little things that you need to know along the way. So let's go ahead and look at our first example, and that is if I'm given the pH of 9.2, see, I'm given a pH. I'm supposed to find the hydrogen ion concentration for a pH, if given the pH, and the hydroxide ion concentration for a situation where I'm given the pOH. Calculations will be identical, as you'll see in just a moment. But first of all, to get this guy changed over, we have to take the next largest whole number of the pH. So we're starting at 9.2. What's the next largest whole number? Anyone? Yeah, 10. Okay, so the next largest whole number is over here at 10, and that is our starting point. We're going to antilog 10 by making it the power of 10 in our final number. So let's see how this actually plays out. I've got 10, it becomes the power of 10. There it is. Then I take my 9.2, which is the original pH. And when I take that original pH, I'm going to subtract that from the power of 10, or the 10 that I started out with, or that I rounded up to. Let's put it that way. So we're going to now take and subtract, and we get 0.8. Now, 0.8 is in the right-hand column. And you'll see that 0.8 is going to be between 0.85 and 0.90. And so I would estimate that somewhere between 7 and 8. Yep. Okay. So what I did with the 6.5 was probably, oh, I'm sorry, it was 6. We're going to antilog this to get 6.5. Yeah. So that comes from the 8, and the 8 is going to be between a 6 and a 7 in the number on the left. And what I'm looking at is this chart right here. So this is where the 6.5 comes from. And you can see this is a pretty simple operation. We're estimating in this chart, we are starting at, what was it, 0.8. Okay, the 0.8 is sitting over in this column between the 7.8 and the 8.5. So it's going to be a little over 6. And that's why I called it 6.5. You could have called it 6.1, 2, 3, 4, or 5. Wouldn't really matter, because you're going to get close enough to the answer that you can do a multiple choice question. So here I am. If you take notes on these before you continue the video, you will then be able to do the practice problem and check yourself and make sure that you're doing it right. So I'm not going to make this a long video. It's going to be very short. So here we go. Start with this and try it out. See how you do with it. You want to check to be sure you can do this, because all of your homework problems involve this. And of course, you'll see these kind of problems on your quiz. Okay, here's the steps. the next largest number above 4.8, largest whole number that is 5. That becomes your power of 10. Subtract the 4.8, which was the original POH, from 5, and that will give you 0.2. 0.2 as a log is going to translate back to somewhere between 1 and 2 on numbers in the left-hand column. And so I estimated it at 1.5, and that's your hydroxide ion concentration. I hope you find this helpful.